Hello everyone. I will now begin the presentation for our Capstone Design 1 project. Our team's topic is the Pohang Buk-gu environmental protection using sensor network. Recently, there have been concerns about the release of harmful substances in the new Yongilman industrial complex in Pohang's Buk-gu area. This is compounded by the localized nature of air quality information provided by the city and limitations in post-environmental impact assessments. To address these issues, a real-time monitoring system for harmful substances using IoT and wireless networks is being established. The system aims to ensure stable long-distance networking, accurate measurements data, and efficient database management. Additionally, it seeks to enhance accessibility for citizens by visualizing real-time environmental information through web and mobile applications. The overall design includes creating sensor nodes for formaldehyde, strategically placing sensors, and addressing communication and power supply effectiveness. Next. The presentation order is as follows. Here is our following presentation outline. First, introduction. Second, problem background description. Third, problem definition description. Fourth, the result of previous studies. Fifth, approaches and initial result. And for the last, project final objectives.
Pohang City currently uses 11 measurement stations to provide information about the air quality. However, this setup has some gaps and has difficulties in measuring the air quality within a local scope, especially when it comes to knowing right away if there are any harmful substances coming from the Yongil Bay Industrial Complex. Additionally, environmental conservation plans and post-environmental assessment face various limitations, including temporal discrepancies and challenges in continuous monitoring. Our project aims to address industrial environmental challenges by implementing a monitoring system based on IoT and wireless networks. We face constraints such as ensuring stable networking, resolving power supply issues, and providing accurate measurements. Our objectives include establishing a reliable monitoring system and improving public information accessibility. The system will function by measuring hazardous substance concentrations in real time, transmitting data wirelessly, visualizing information through web and app interfaces, and enabling citizen reporting when pollution exceeds thresholds. Through these efforts, we refer to creating a safer and transparent environment in industrial areas.
I will introduce the result of previous studies. Our team was able to find the existing research data and papers related to our project. And during the researching process, 3 research data that had the greatest similarity to our project will be found. First, I will present the research data which is EIASS. EIASS is known as Environmental Conservation Plan and the Post-Environmental Survey. This research data help us figuring out how new industries affect the environment nearby the factory. It is a government policy to prevent destruction and environmental pollution in advance. And it makes sure we grow in a way that keeps our surrounding nice. Each tool has pros and cons. On the good side, EIASS let us look how industrial areas might impact the environment comprehensively. But here's a tricky part. We are not always keeping an eye on how the bad stuff from these areas affect nearby facilities, since there is no continuous monitoring system. In addition, there is a gap of 1 to 2 years between the actual investigation period of post-environmental survey and the publication period of the report. Therefore, it is difficult to continuously figuring out the effects of harmful matters from the industrial complexes. Air Korea. Our second research is Air Korea, which is a real-time solution. It is operated by the Korea Environment Corporation and designed to provide the public with instant access to air quality information. It collects data from all over the country and shows us what's happening in real time. This system is like a guard, protecting us from the bad air. However, Air Korea has strengths and weaknesses. On the good side, it allows users to check the air quality status for 8 things in the air, following local rules. But it has limitations. It only considers the air overall and might miss specific areas like industrial zones. Also, it only checks for 8 things, potentially leaving out other harmful substances found in industrial areas. Our last data in a research paper called IoT-based Air Environment Monitoring System. An IoT-based atmospheric environment measurement device is configured to mount the measurement device on drones and vehicles. This measuring device is equipped with software that collects and analyzes the atmospheric environment. Measurement and analysis results are visualized and provided through our user's PC or smartphone applications. We found out that there were various ways to sense air pollution.
I will present our approach to the problem we have defined, and also I will share the preliminary result obtained through the Capstone process. Firstly, I will discuss the key approach. The key approach explains how we started approaching the problem we defined. We have defined the issue of potential emissions of pollutants due to the development of an industrial complex in the northern district of Pohang. Our goal is to develop sensor node which can effectively measure airborne pollutant. In order to measure pollutant accurately, we plan to monitor real-time air quality based on the appropriate facility near the industrial complex, power supply, networking, and sensor system at that location must be completed so that information can be checked in real time. Before the developing sensor node for the final project, we conducted a mini project by defining locations on campus that require monitoring. Through this process, we were able to acquire fundamental knowledge that is necessary for the development of sensor node. Firstly, we conduct network practice by equipping a ZigBee module on Arduino Uno. This photo shows a ZigBee module mounted on Arduino Uno using the XCTU program. We implemented one-to-one communication and a star-shaped network structure.
Secondly, we conducted practical measurement of pollutants on campus. For the experimentation, we used sensors like MQ7 for CO, MQ2 for flammable gases, sensors for fine dust as well as for temperature, humidity, and CO2. The spots for our project were the 3D printing room, smoking area, dormitory, and large lecture hall. We placed the sensor node in those locations and store sensor data in the database every second. Arduino get information from the attached sensor through serial communication. Arduino communicates with another Arduino or Raspberry Pi using the ZigBee protocol. The sensed information can be transmitted in structured format. The network protocol that we use is
Zigbee, which has the benefit of low power consumption and ease of implementation. Communication between sensor node and gateway were implemented through Zigbee communication. When doing the final project, we plan to use LoRa protocol considering the outdoor nature. Raspberry Pi transmit the sensed information received from Arduino to the database using Wi-Fi. We use Firebase Cloud Store service to store the data with the timestamp. Using Flutter, we visualize the data and represent the trend of pollutants in a graphical format. This allows us to observe a real-time pollutant information.
According to the environmental impact assessment of the Yongilman 4 industrial complex, formaldehyde is expected to exceed the risk standard. Therefore, we selected formaldehyde as a key target material. The purpose of our project is to check whether formaldehyde occur in the Yongilman industrial complex and formaldehyde affect schools and residential area. To achieve this goal, we developed a formaldehyde monitoring system. Next, the sensor node is located around the factory, where the risk of formaldehyde is expected. In addition, sensor nodes are also installed in facilities such as Handong University and Yangdeok and surrounding villages. The locations we select are marked with a red dot in the map. The sensor nodes should measure 5 elements. There are formaldehyde, temperature, humidity, wind direction, and speed. The variable formaldehyde must be measured according to the result of the environmental impact assessment. And temperature and humidity need to be measured together because they are factors that directly affect the atmospheric environment. In our project, it's important to measure the variable formaldehyde itself, but it's also important to understand how formaldehyde spread to surrounding facilities. Therefore, the sensor node also measure wind direction and wind speed.
Third, I will tell you about the network part. We will use LoRa or Wi-Fi for communication between sensor nodes. First, LoRa is long distance and low power communication method. If there is no previous established network near the location of the sensor node, the LoRa network needs to be built. Second, Wi-Fi connection can be another option. It is the case of Handong University and Yangdeok with a network built around. In this case, Wi-Fi is used through the ESP8266 module. Fourth, about power supply. Power supplying to the sensor node is the most difficult part of this project. It is necessary to find a proper power source with appropriate replacement cycle so the sensor node can be operated steadily. Fifth, the database. The sensor node transmits data to the Firebase database, so data can be continuously corrected in the database to identify seasonal or periodical changes in formaldehyde. Last is the app and web. User can check environmental information in real time through the app or web. For doing this, we need to design a UI to represent the data effectively. And here is our reference for the presentation. As we wrap up today's presentation, we have the opportunity to create a safer and healthier surrounding environment through this system. Through ongoing management and collaboration, we want to contribute to the safety and the environmental of industrial facility with this technology. Thank you for your time.